Hi guys, welcome back to my channel Pirai Academy. In the series of Zoho interview question, today we are going to see a question called maximum subarray. Given an array of integers, find the contiguous subarray with the maximum sum that contains only non-negative numbers. If multiple subarrays have the same sum, return one with the smallest starting index. If the array contains only negative numbers, just return -1. So a subarray is a contiguous non-empty sequence of elements within an array. So basically a subarray is a subsequence of the array, okay, or a subset of that array which contains the element in that array in a order and also contiguous. Meaning for this array 1 2 3, okay, the subarray are either 1 or 2 or 3, otherwise 1 and 2, otherwise 2 and 3, otherwise 1 2 3, whatever, okay. But 1 and 3 cannot be a subarray, okay, and 2 1 cannot be the subarray because it is not in order, right? But 1 and 3, whether it is a subarray, no, because this 2 is left over, so it is not a contiguous. Contiguous means continuous, okay. Now hope you understand what is meant by subarray. But in this question there is somewhat one thing is not explained well, okay. I will be telling you that. Okay, fine. Now let us see this problem's example. See this example. They have given 1 2 5 -7 2 and 6. If this is the array, then our output should be 1 2 and 5, okay. So this should be my output. How? Because see here, they are asking us to find the maximum subarray, right? So this will be some lead to 8 and this will be some lead to 8. Other than that, there is no maximum subarray, right? And these two are of equal, right? So I want to take a smallest starting index. That's why I am taking 1 2 and 5. Hope you understand this, right? So this is the basic explanation. Now how to do this? So we can do this by using a simple brute force approach. What is a brute force approach? To do this in a easy way. So it is not an efficient way, but it is a easy way. So how to do this? So first of all, I want to generate all possible subarray, right? So generate all possible subarray. Then just to find which has all non-negative. Every element should be non-negative. And also its sum is greater than all possible generated subarray, okay. So sum should be greater. Then I want to return that resultant array. So these are the three steps that are involved in the brute force approach, but it is inefficient. How much inefficient it is? Of time complexity of O of n cube and space complexity of O of 1. So this much it is inefficient, but we want a efficient solution. So how to optimize our this logic into an optimized version? Okay, fine. So to do this, let me take some of the values. So fine. Now just listen this carefully. Start, okay. It is a starting point of the current subarray, okay, and the final start is the starting point of the resultant subarray. And the end is the resultant subarray's ending point, and the sum is the sum of the current subarray, and maximum sum is the sum of the resultant subarray, okay. So just keep this in mind and just follow me. I will be giving you the algorithm. So to optimize this brute force approach, we are going to use sliding window technique, okay. So it is not basically a strict sliding window technique. We can tell this as a two-pointer technique instead, okay. Initially I will be starting from here, okay. First of all, it is 1, okay. So whether 1 is non-negative, yes, it is non-negative. So what should I do? I should be adding in my current subarray sum, okay, 1, okay. So current subarray sum is 1. And what is my maximum sum? My maximum sum is initially -1, okay. So 1 is greater than -1. So in this case I want to make what? This as 1. So many of them will be having a doubt at first, why this maximum sum is -1, right? Now hope you understand this. We only want the non-negative. Non-negative means 0 is also a non-negative. So if 0 should be also greater than this minus 1, right? Can you understand this? That's the reason why I just initialized as minus 1 for the maximum sum. Fine. Now, the sum is just updated in my maximum sum. So, what are the things I want to do? The start point is what? 0, right? So, final start should be updated as my start point. So, which means the current subarray sum is maximum than the all possible subarray sum as of now. That's why I am just updating my final start with my start. Okay, and end will be also updated with the current index. Okay, fine. Now again go here. What is it? It is 2. So just update here. This is 2. Fine. Sorry, 3. Sorry, 3. Fine. Now 3 is greater than this 1. So update this as what? 3. So when I updated this as 3, I will be updating this as 0 and updating the end as 1. Hope you understand this. Next step, going here, 5. So it will be 8 and update this as 8 and update this as 0, update this as 2. Okay, fine. Now comes the twist. See here, what is the number? It is negative. Whenever we are just striking the negative, then what should we do? We should be just skipping or just make the front part of the subarray as a separate. Okay, so I want to reset, meaning I want to make my sum as 0, which means, hey, from now the previous subarray is not in my hand. I want to go to the new subarray, like that. Okay, and I want to just make my start point as current index plus 1, because it may be non-negative, right? So I will make this as 4. That's it. Okay, now again traverse. Now here comes 2. When it is 2, my sum will be what? 2. But whether 2 is greater than 8? No. At this case, don't do anything. Okay. Then again come here. It is 6. So 6 we will be adding here. It will be 8. Okay, 8 is whether greater than 8? No, it is equal to 8. So don't care because we always take the starting point as a smallest, right? The starting point will be smallest in the 0th index, not in the 4th index, because here the starting point is what? 4. But our best solution answer is what? Starting index is 0. So we will be not doing anything. We will be skipping to the next. Okay, so skip. Here there is nothing. So stop here. Finally, what is my final start? Final start is 0. And what is my end? It is 2. So I can say the index 0, 1 and 2 are the answer. So what are the corresponding elements? So it will be 1, 2 and 5. Okay, and also I want to tell you some edge case in this problem. So actually they didn't explain in the well manner. So just see here, if this is the case, then what will be my answer? Whether I want to take 1, 2 and 5, or I want to take 1, 2, 5 and 0. So there is a contradiction in the problem statement, right? In problem statement, either they can tell you that we want to take the highest length. Okay, the starting index is same here. Here also 0th index only the starting point, right? But they also given one more parameter, like whether length will be minimum or maximum. But here the length will be maximum in the question. I mean the problem statement is wrong. Okay, that is somewhat error. Okay, so just add in the problem statement like the subarray size also maximum. Like first of all, we want to check the maximum sum, right? If maximum sum is tie on maximum sum, then we want to see what? Smallest starting index, right? If this is also same, which means tie, then we want to return what? We want to return the largest length subarray. Okay, so if they have given this additional parameter, then the question will be more appropriate. Okay, So for just overcoming this problem, okay, I will be just checking whether the current subarray's length is greater than the previous subarray's length. Then I will be just updating my end to the current subarray length. Can you understand this? If this is one of the case and this is one of the case, then I will be updating this. Can you understanding this? I will be showing you clearly in that code. Okay, don't worry. Now tell me, what is the time complexity? Time complexity will be O of n and space complexity will be O of 1. Hope you understand this, right? Because we are just traversing that whole array one time and we didn't took any auxiliary space. So it is much more optimized than the brute force approach. So let me show you the code. I always prefer a Java code. Okay, sorry, Java. Okay, initially these are the initial setups. Okay, now I am going to traverse in that array and I am checking whether the current element is a negative element. If it is so, then what should I do? I should be making my sum as 0 and start point will be current end is +1 and continue to the next iteration. Okay, or else what should I do? I should be adding my current element to my sum and I am checking whether sum is greater than my maximum sum. Okay, if it is so, then I will be doing what? Maximum sum is equal to sum, final start is equal to start, and end is equal to I. Okay, this is what I told you. Then I will be just checking whether the maximum sum is less than 0. If it is less than 0, what it mean? It mean we don't have any non-negative value. We only have all negative values. In that case, I will be returning a -1. If not, I will be taking from the final start up to the end and just adding every elements into the result and returning the result. Okay. Let me submit this so that you can understand what is the problem with this code. And I told you, right? So that error will be occurring. Just see here. Yes. So see here. This is the input. Okay. This is the input. And your code's output will be like this. But what is their code output? They are adding 0 also. Can you understand this? Yes. So it will be more appropriate if they have given that parameter like it should be a largest also in some type cases. So we want to add this statement here. Okay, if the current subarray sum is equal to the previous or the better subarray sum. Okay, in other words, the maximum sum. Okay, and also I minus start, which means the current subarray's length. This means current subarray length is greater than the end minus final start, the maximum subarray as of now, the resultant subarray's length. Then what should I do? I should just take the current subarray as my resultant subarray. Can you understand this? If there is 1, 2, 5 and 1, 2, 5, 0 as an individual array or subarray, then I should be taking the largest length. Okay, largest length. Can you understand this? So that's the reason why I am having this one simple statement, but it is inappropriate to this question. I don't know why they didn't mention this. Okay, let me submit it now. Yes, it is submitted successfully. To know about these kinds of algorithms, just go and watch my YouTube video. And if you really like this video and subscribe to my channel. Don't skip any videos in this Zoho playlist, because every videos there will be quality content so that you can crack this round. Thank you.